We're going to look at the hyperbolic function, they call it here, a hyperbolas. And there's something to sort of notice special about a hyperbola. It's got two axes of symmetry. What's an axis of symmetry? Well, it's a line that will cut the function into two equal pieces. So you could fold one piece and the other. Well, you see this branch here and this branch here. If we drew a line right down here, we could fold this over in here. It's a mirror image of it. Also, this would fold this way. This arrow would fold down over here, where the line y equals x. For the functions we work, the line y equals x at a 45-degree angle is one axis of symmetry. And the other axis of symmetry is y equals minus x. So even later on in grade 11 and 12, when we look at hyperbolas, we look at functions that have an axis of symmetry with the positive gradient, that's 1x, or with a negative gradient, minus 1x. Well, the only thing that changes with our gradients, they're really kind of, our axis of symmetry. The axis of symmetry of any one of our hyperbolas is really easy to find because you just go to the y-intercept, and that's the axis of symmetry. Y equals x plus 5. If it goes through, you look at the point where the y equals q, the asymptote. It's not the y-intercept. It's the horizontal asymptote, the one that you use to draw the hyperbola. If you go to that q and just add that q, you'll get y equals x plus q is the axis of symmetry with the positive gradient. And minus x plus q is the one with the negative gradient. That's it for axis of symmetry. Okay, let's try and take a look. Say you're given this picture and you're asked to find the equation of the hyperbola. Well, you know it's a over x plus q. Well, q is the easiest thing in the world. If you know that this is minus 3, then that's what q is. So the number added on must be minus 3. Well, and then they give you another point, 3 and minus 4. So it's the same story. We take x and we substitute in 3. We take y and we substitute in minus 4, like we do with all functions. Now we just have to solve this. We add 3, we get minus 1. Then we multiply by 3 and we get a equals minus 3. Okay, well now that's it. We've got the equation right there. The equation is y equals minus 3 over x minus 3. We didn't write the final solution down here, or I left it out of the notes. But that's it for doing hyperbolas. You see your answer there. I know it's negative. It puts the branches in the second and fourth quadrant, so it should be negative 3. So that should make sense to you. Okay.